Well, here's a job I needed to do. I needed to make some parts, but I needed two pieces of steel, the same thickness, same length, and same width. Now, unfortunately, I had only one piece of steel suitable. But what I did have was a piece of plate which was same thickness and approximately the same length, but a lot wider. This was 6 inches, and the other one was 3 inches. So what I needed to do really was to go down the centre of it and split it. Now I tried a grinding wheel, cutting off wheel at first, but that was a no go, and the bandsaw wouldn't touch it. It'd take me forever, and I don't know how many blades I'd use trying to cut through this. So the only option really was to set it up on the miller and put the horizontal setup on, put a slitting saw on, and slit it in the old-fashioned way. So this is the procedure which I adopted. And this is the vertical head on my senior miller, and it needed to come off. I was a bit reluctant to take this off because sometimes it could be a bit of a fiddle getting the thing back on, but there was no other way. And this is the overarm support casting, which I haven't used for quite a while, and a little bit of rust in the bore, but a little bit of a clean up got rid. And there's the arbor, which has two slots, two flats on the end, which fit into the tang in the machine head. I'll just taking out the cutter which I'd left in. I don't want to be taking the head off with the cutter still in, and it could result in some nasty cuts. And then undo the nuts for the base. And once the nuts are removed, it's fairly easy and straightforward to pull it off. Not as easy to get back, I might add. And there's the driving tang on the vertical head, which mates in with the slot in the spindle of the machine, and that's what drives the horizontal arbor. Now I just need to wire these two bolts up out of the way so they don't fall down onto the arbor when it's in place. Now the arbor is seated into the spindle of the machine, and the two flats engage the driving slots in the spindle. And now what I'm doing is tightening up the drawbar so that the arbor is seated firmly on its taper. Next job, undo the locking bolts for the overarm, and this will then be pulled out, and then the overarm support can be fitted. Quite a heavy lump of steel is this overarm. It's 2-inch solid steel bar, quite heavy. It's a matter of getting out back of the machine and undoing the other bolt which clamps down the overarm. A little bit awkward where my machine is placed. Really could do with pulling it out a little bit, give myself a little bit more room. Now it's just a matter of pushing the overarm out to the required distance. It's quite a heavy lump, is this. It really does provide some good support for the overarm. get it in position, and then the locking bolts and are retightened. Now the locking bolts can be tightened up, and then the support casting can go on and slide onto the arbor. That's the bronze bush there, which inside that runs a hardened steel bush which fits on the end of the arbor. Well, that's just about positioned where I want it. I just need to get
all it needs now is a cutter.
the gearing sorted out. I'll just drop down into back gear, which will give me a lot slower speed for the slitting saw I'm going to use.
And everything seems to be running free there, no problems. Just need a squirt of oil.
Now this is the 6-inch cutter I'm going to use to slit the plate. I don't use keys in my cutters. I just make sure that everything's tightened up fully, and I found that works okay for me. I find that if anything goes the key way, gets sheared, and sometimes they can be a bit tricky getting off the arbor. Now what I intended doing originally was to clamp down the plate and slit the plate down the middle of the T-slot. I've done this before and it's always worked out quite well, but I decided not to bother on this occasion with it being so long. I was going to make sure that the scriber matched on either end of the table so that it would miss gouging out any of the T-slot sides. But I decided not to bother doing this. I eventually raised it up in the correct way and give enough clearance underneath so that the cutter would not get in way of the table. Now this is the plate packed up with some packing blocks, and then what I shall do now is just clamp the whole lot down. Make sure that the scribe line on the plate is parallel, and then everything should be okay to go.
Decided to raise the plate.
Now to make doubly sure that the plate is parallel with the table, I usually put some blocks into the T-slots, and then just put the plate up against these blocks, and it ensures that everything's parallel. It always works well, does this, for jobs like this. And then it's just a matter of clamping down everything. Clearances can be a problem when using clamps in situations like this, so you've got to be very careful where you position them, otherwise things start fouling. Right now everything is clamped down. It's just a matter of putting the spacers on the arbor so that the over arm casting can be fixed on and tightened up. It's a very simple type of overarm casting, is this, but it's very effective. It does the job. We've just got to make sure everything is clear, and the clamps aren't going to foul the arbor. The overarm bar can come out a little bit more actually. I've now moved the overarm bar out a little bit more, and I'm now in the process of tightening up the arbor to clamp up the cutter. Now this is one of the micrometer spacers. You don't see many of these about, but you can actually put these on the spindle and adjust distances between various cutters if you're doing gang milling or up to shoulders. You won't think they'll be strong enough, but they're actually marked in thousands of these, and they're quite effective.
A drop of oil.
Now I have slowed down the spindle a little bit more because I found the previous speed setting was just a little bit too high. A good oil in now and we're all set to go. Now the milling machine bed is at its extreme limit at this point, and it should just about cut through this length of plate, hopefully. A good drop of oil on the spindle there, and we'll set it going. Unfortunately, the senior M1 miller does have auto feed, and it will also automatically knock off at the end of the limit. Now on my particular senior miller, I altered the gearbox slightly, the gearbox feed, and it will feed from both ends, whereas normally they'll just feed from one end, well from this end actually. But with having a tumbler reverse on the gearbox, I can actually feed also from the other end, which is very useful. Now I do need to cover that white storage box up in future if I take more video on this miller. It's causing no end of exposure problems. I couldn't understand why the cutter was cutting out of true, because I do know that the spindle is not bent, and the cutter's only been used a couple of times, and that's no teeth missing from it. I couldn't figure out what was up. I did find out later on. It was something of a bit of a surprise, really. Although it was out of true, it was cutting okay. There was no problem. Not until we got to the middle section where there was not as much support, and then it started protesting a little bit. And there's a quick view of my modified gearbox with the tumbler reverse. Here you can see where it's been raised up off the bed, and it's still more or less in the slot area, the T-slot area, but there's plenty of clearance for the cutter there. Now this is the auto stop. When this block gets to this knob here on this lever, it just knocks it forward and the machine feed stops.
Just going through my my cutters, sorting out the slitting saw. I just thought to show you one or two of my other cutters what I have. It's very rarely used. A big convex cutter there. And there's for cutting radiuses, that's an odd size. There we have the standard V, I think that's 60 degrees, yeah, 60 degrees. Very rarely use these. It's mainly the concave and convex ones which I use. I've had these many years. It's very rarely used them now. Same with the angular cutter. They're always handy, you never throw them away. They're quite expensive to buy. And these are actually some of these are actually brand new and never been used. Once I get blunt, it's easy enough for me to sharpen them on my cutter grinder. And here we have another angular one. This is 60 degrees. Never been used. It's still in its what we used to call crow cell dip that preserves the cutting edge. One ear tuned to the noise there. Anything goes wrong, I'm there. Here we have another larger concave cutter, and here's a small one. And I believe that one's that's the male and that's the female. Not too sure. I think it could be. And there we have making a bit of a noise now. It looks like it's getting towards a halfway point. But there's the standard side helical cutter. Very useful. Small side and face. There we have another one. Another convex. There's a large side and face, which is very, very useful. And another side and face. Again, very useful cutters. I need to see to the saw there, it's protesting. Everything's cutting okay, but it's just making a noise where it's less supported in the middle. It should be okay. I've done it before when I've cut lengths of steel like this. These side and face cutters are very handy, and if you've got a pair, you can actually, a pair the same size, you can actually go down, you can actually machine, if you've got a pair like both same size, you can actually machine down grooves or centre sections or everything, and they're very useful. They're a little bit tricky to grind in this size, but this is still quite sharp. The convex cutters though, the only way to sharpen these is on the front face, because all these are form relieved. So no matter how much you grind off the front face, it never loses its form or shape, or size I should say. So it's always constant. It's just that you sharpen on the front. And it's exactly the same with these. And these are milled form relief, they're not ground, but they do the job. And it's the same thing. The more you grind off the front face, the thinner the tooth gets, but it still keeps its form and size. Same with this one. This has had quite a lot of regrinding, as you can see. It's quite thin now. It still works. And this one's virtually new, never been hardly used. It's never been reground. They've all got keys, as you can see, but I never use keyways, because they always end up shearing and it's a devil sometimes to get them up. And now we're getting near the limit now to where the stock will knock the machine traverse off, and then it means that the whole lot will have to be shifted again and reset, and then the slitting saw then will cut the rest. I think in a previous video I did mention all my slitting saws which I do have. And there's quite a variety, different sizes, different thicknesses and different diameters. Some of them are quite small. In fact, I have a slitting saw somewhere where it's about 6 or 7 pound thin. And I use that for slitting piston rings. There with a very thin one there. They're very useful sizes. And this is a very, very fine tooth slitting saw, and that's your standard run of the mill. A very good quality. Summit, they're a well known make. getting close to the machine knocking off now. But this is a slightly modified one done on a rotary table, a rotary grinding table. And that's a very coarse tooth one, but it works fine. And here we have another form relief, but this is ground form relief. It's slightly different the way that's been form relief. It's done on a grinder. And there we have miniature side and face cutter. And there we have another one. And that has a radius on the top of the teeth. Very useful. There we are. It's knocked off. And now I need to ship the whole lot.
Now I need to rewind the table back now and just reposition the plate so it cuts the last couple of inches, and that should separate the plates. An important job waiting to be seen to. My granddaughter's Thomas tank engine. There's the plate which has been repositioned, and now we'll cut to the end of the plate. The clamps will have to be slightly moved out of the way, because otherwise I believe there's a chance of the wheel fouling. Now here's a close-up of one of the spacers which go on the arbor of the milling machine. They are actually a micrometer type of spacer. They're graduated in thous. You wouldn't think these would be really strong enough to take the amount of pressure when tightening up on the cutter, but they do. And they're very good for accurate spacing. I used to have a couple more of these, but they've unfortunately disappeared over time. Now we're getting to the end of the plate, and it's getting very, very close to the clamp. So this clamp needs now to be repositioned. In actual fact, I did not bother with the clamp, as you can see. It was clamped down enough to just finish this small section at the end. Well, that turned out okay. No real problems, just a little bit of vibration due to the arbor out of true, I suspect, and also the plate wasn't properly supported in the middle. But it's come out quite good. I'm quite pleased with that. Just deburr the edge, and that's the job finished. Cutter's okay as well. No broken teeth or anything. It still feels sharp. Now, the reason for the spindle being out of true, I discovered when I were dismantling the overhead arm and the arbor, is that I hadn't fully tightened up the drawbar. I thought the drawbar had pulled everything into place and everything was seated, but it hadn't, and the taper was not seating in the spindle. It was being driven by the tangs, okay, but that slight looseness threw the arbor out. I don't know how I managed to do that, but that was the cause. When I fully tightened it back, everything run true. Well, I hope you found this of interest, and once again, thank you for watching.